Hi, so my project consists of a temperature controller, similar to a module that controls a car's ventilation system, or even a thermostat. It also monitors the ambient temperature and humidity, and then it displays it on the LCD screen. So my original inspiration for this idea was a real-world problem that I encountered on my home. My basement is very humid and the temperature can get either very hot or very cold. So naturally, an automated device that can control temperature and humidity would solve the problem. My project aims to complete the task of controlling the temperature and displaying info about the ambient air. Originally, I wanted to connect the Arduino to a DC motor to power a fan when the temperature gets too hot, similarly to a fan in a modern computer. However, the wires on the DC motor are ridiculously fragile and broke off during initial assembly. So I changed that aspect of the project and used a servo motor instead to operate a sort of flap which controls airflow, like the ventilation system in a car. So connected to the Arduino are 5 different components. There is a temperature and humidity sensor, an LED screen, 2 buttons, a blue LED light, and the servo motor. The device is simple and efficient, so no additional power source is needed. It's entirely bus powered. So the servo motor is connected to the Arduino, the temperature and humidity sensor as well. Connected to the breadboard, there's the LCD screen, and then there's the potential meter, the LED, the blue LED, and the 2 buttons. So the left button is the power on and off button, while the right one is the toggle between automatic mode and manual mode. The LED is going to light up when the flap is open, and the LCD is going to show the set temperature, the mode, so automatic or manual, the ambient temperature, the ambient humidity, and also the status of the power, off or on. So now I'll show how the device works. So when you turn it on, it's like it says here in manual mode and it's always off. And the button A here is what controls the power. So it's a power button. When you click it, it goes and it turns on. And when you click it again, it turns off. As you can see, when you turn it on, the blue LED lights up and here it changes to on. So I'm just gonna turn it off again. And then this button changes it to automatic mode or back to manual. So when I click it, it changes to automatic. And since the temperature I set is 20 degrees and the ambient temperature is 20 degrees as well, it stays off. However, if I go into the serial monitor on the computer here and I set the temperature to 19 degrees, which is lower than the current ambient temperature. If I set that and I click enter, it changes the set temperature to 19 degrees and it automatically turns on. Now from this perspective, we can see what the servo motor is doing. So the Arduino is over there and I just built a very quick demonstration here. So when you click on, it's going to open this flap and let all the air current in to cool whatever you're trying to cool. And then when it reaches a temperature, it's going to automatically turn off. And when it turns off, it closes the flap again. So last demonstration, I want to show how the auto feature works. So now it's on automatic and it's on because the temperature is still very high, but it's soon going to get to a lower temperature than what I set, and it's going to turn off automatically. There we go. So now the temperature set is 22, but the ambient temperature is 21, so it has turned off the flap. All the functions work as intended and are immediate. However, the button to switch between the automatic and manual modes sometimes does not respond when I click it. It might be a problem with the button itself or an inefficiency in the code that makes it skip. The device does not overheat and draws very little power as intended. However, the motor is quite noisy, but that is a constraint of the equipment I had available. Also, while the motor is moving the flap, the LCD dims in brightness because the motor draws more electricity. The screen contents remain visible, but it's a flaw. Well, in conclusion, the device I constructed works with minimal lag and with little power. The code is quite efficient and reliable. The device reacts to open and close the flap as soon as the temperature reaches the desired point when it's in automatic mode. So it succeeds in doing its design task of controlling an airflow flap while monitoring the temperature and humidity. Another key achievement of this project is the code used to power the logic of this device. So I learned how to use conditional statements and various other functions that I set up in the Arduino. Thank you for listening.